In the current session, we will discuss tensor notation. For that, consider an n-dimensional space. Let x superscript I be any set of coordinates in that n-dimensional space. We should read this as x superscript I, not x power I. X superscript I indicates x superscript 1, x superscript 2, x superscript 3, and so on. Let x superscript I be any set of coordinates in the n-dimensional space. Let x bar alpha be another set of coordinates in the same space. Now, we can say each of the coordinates x superscript I will be a function of the n coordinates x bar alpha and vice versa. See this? X superscript I equal to x superscript I is a function of x bar 1, x bar 2, x bar 3, and so on. Here the value of I greater than or equal to 1, less than or equal to n. In the same manner, x bar alpha is a function of x1, x2, x3, and so on. Here alpha greater than or equal to 1, less than or equal to n. Now find out the value of dx superscript I. Dx superscript I is equal to dou x superscript I divided by dou x bar alpha into dx bar alpha. Here we have to use the summation symbol. Alpha equal to 1 to n. The value of I greater than or equal to 1, less than or equal to n. In the same manner, dx bar alpha equal to dou x bar alpha divided by dou xi into dxi. Here the summation or I equal to 1 to n. Here the value of alpha greater than or equal to 1, less than or equal to n. Einstein introduced a summation convention. According to him, if an index is repeated in a term, summation over it from 1 to n is implied. See this? Capital A equal to ai ui. Suppose I equal to 1 to 3, we can write this a1 u1 plus a2 u2 plus a3 u3. A equal to summation over I equal to 1 to 3 ai ui. Then the summation implies addition of the things. Therefore, we may present the equation dx superscript I without using this summation as dou x superscript of 5 divided by dou x bar alpha into dou x bar into dx bar or alpha. In the same manner, dx bar alpha equal to dou x bar alpha divided by dou xi into dxi. Now we may call a term free index. If an index appears only once in a term, is called free index or real index. See this equation. Ai equal to bij cj plus dik ek. In the above equation, I is the free index, but j and k are called dummy indices because the index I is present at only one time, whereas j and k are present more than one time. Therefore, I is called free index, J and K are called dummy indices. Now we should go for dummy index. An index which is repeated and over which summation is implied is called a dummy index. See this equation, AI, Bj, Cj. Here I is real index, J is dummy index. If you expand this, AI, then B1, C1 plus AI, B2, C2 plus AI, Bn, Cn. Here the value of J is 1 to n. See this AI into B1, C1. 1 and 1. These two are appeared 2 times. 2, 2. Then n. Therefore, the index J is called dummy index, whereas I is called real index or free index. In the above equation, I is the free index and has a fixed value between 1 and n. The term J is a dummy index. The dummy index can be replaced by any other index which does not appear in the same term. See that we may replace the dummy index by some other index. The necessary condition is the substituting index will not be appeared in the term previously. Say here, AI, B, J, J is equal to AI, B, K, K equal to AI, B, L, L. Say this is a dummy index. Bjj is a dummy index. This dummy index is replaced by another index Bkk. Then the Bkk can also be replaced by Bll. Anyway, this dummy index Bjj can be replaced either by Bkk or Bll, but the meaning is same. Next one is Kronker's delta. Dx superscript I divided by dx superscript j is del ij. Dx bar superscript alpha divided by dx bar superscript beta is equal to delta of alpha beta. We may expand this in this form. Dou xi divided by dou x bar alpha dot dou x bar alpha divided by dou x j, that is equal to del ij. The same manner we can expand this also. The value of Kronker delta equal to 0 if I not equal to j. If I equal to j, the Kronker delta value equal to unity. We may express the Kronker delta in terms of a matrix. Del ij equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. If you write the delta in terms of ii, that means I equal to j, then del 1, 1, this is del 1, 1, plus del 2, 2, plus del 3, 3 equal to 3. This is the first element in the first row, second element in the second row, third element in the third row. See this matrix, first element in the first row, second element in the second row, third element in the third row. Del ia equal to del 1, 1 plus del 2, 2 plus del 3, 3 equal to 3. Kronker delta removes the dummy index. See this del km into del lm. Here m is the dummy index. So these two are reduced as del kl. If you consider this equation, if k equal to m, the value of del km is unity. Here if L equal to m, then this del Lm is equal to unity. Therefore, by the way of replacing this m, we can write del Km into del Lm equal to del Kl. Therefore, we can point out the Kronker delta removes the dummy index.